right, ladies and gentlemen, so today we're going to work on another way that we can solve these systems of equations using algebra, but this time we're going to be using something called elimination. And elimination is when we add or subtract the equation so that one of the variables drops out. All right, so remember, we can only go through and use our process of solving if we have the same variable. If I have two variables, I can't do it. I have to do something else to it. So if we take a look at this, all right, in order to have this happen, your variables, in order for it to drop out, it has to have the same coefficient but opposite signs. So see up here it says that, and we're going to have those aligned. Well, that means that they're going to be one on top of each other. So when I look at my two equations, I have 4x, 6y, I have 3x minus 6y. Well, I notice that the y's have the same coefficient, but there's opposite signs in front of them. So I can now take and add these two equations together. So I'm going to draw a big, I'm going to erase this here. I'm going to draw a big line. Right, so we're going to put these together. Well, if I have 4x's plus 3 more x's, that's combining like terms, 7x. Well, if I have 6y minus 6y, those have canceled themselves out, or they've been eliminated from the problem. Over on this side, 32 plus 3 is 35. So now I have an equation that only has x, and I can now go about and finish solving this. So to get x by itself, we're going to divide by 7 or multiply by 1/7. So I'm going to get x equals 5. Well, remember, when these are systems, our solution has to have, it's a point on the graph, so it has to have an x value and a y value. So now we're going to take this x value, I know x is 5, and I'm going to pick one of my two equations to start with. Does not matter which one. I usually take the one that has the smaller numbers or the one that looks like they're going to be positive. But again, it doesn't matter. So I'm going to just end up and I'm going to go into the first equation. So I'm going to copy it over, similar to a check, except we don't have two numbers to put in, we only have one. I know x is 5, so I'm going to take x out and I'm going to put 5 in. So that means 4 times 5 is 20. So now I'm left with another equation to solve, this time to figure out what y is. All right, well, I know how to solve this. To get y by itself, I have to cancel my constant first. So 6y equals 12. Divide both sides by 6, so y is 2. So the solution to this problem, the point of intersection that works, is, the point 5, 2. 5 is your x, y is your 2. And again, if you had put this in here, you would have ended up with the exact same answer if you did your math correctly. All right, now looking over here at letter B, this time when I look at my equations, I notice that the coefficients of x are the same but opposite signs. So I can add these two together and the x's are going to drop out. Negative 3x plus 3x, those cancel. Positive 4y, negative 6y is going to give me negative 2y, integer rules. 12 plus 18 is going to give me 30. Divide both sides by negative 2, and we get y is negative 15. Now I have to go back and figure out what x is. Again, it doesn't matter which one you pick. I'm going to pick the top one just because it's first. So we have negative 3x plus 4y equals 12. I now know y is supposed to be negative 15, so I'm going to put that in here for y. Excuse me. 4 times negative 15 is negative 60, so I'm going to write that as a minus. So now I have to get x by itself. So we have to add 60. Negative 3x equals 72. Divide both sides by negative 3. So x is negative 14. Double check my math, Paul. I know you love to do that. So my solution, the point that works for these, is the point negative 14, negative 15. If I were to have graphed both of those, they would intersect at that point on the graph. All right, so again, it's new. We're going to go slow. We're going to spend a couple of days on it. All right, so let's see if we can find here. It says -3 times one number plus 5 times another number is -11. So they're making us write our own system. Well, I'm going to start with my let values. So I'm going to let x be one number and y be the other. Okay, so let's see what these are going to look like. It says -3 times one number, -3x, plus 5 times another, plus 5y, equals -11. Then I have 3 times the first number, which was your x, plus 7 times the other is -1. So now I still want to try to solve these using elimination. If I look, I have 3 for the x's, one's positive, one's negative, so I can eliminate the 3 simply by adding these two together. So those are going to cancel. -3x plus 3x cancels out. 5y plus 7y is 12y. -11 plus -1 is -12. Finish solving, and I get y is -1. Again, then I'm going to put that into one of my equations. Sorry, I know the screen's moving. Put the -1 into either one of the two equations I wrote. I'm going to pick the first one just because it's written first. So -3x plus 5y equals -11. I know y is -1. So -3x, 5 times -1 is -5, so I'm going to write it as a minus. So now we're going to add 5 to both sides. -3x equals -6. Divide by -3, so x is 2. So my solution is 2, -1. Those are your two numbers. Okay, for those of you, the key to these problems is to work neatly. So those of you that like to write all over the page and only show half your work and you can't even read your own handwriting, you're going to have a hard time with this. Those of you that can work neatly and show all of your steps are going to have a little bit of an easier time with this. Again, any questions, bring them to class so that Mr. Bush and I can go over anything you need to go over. I know there's still 2 more word problems, or a word problem and a half, but we'll work on those together in class. Any questions, bring them with you.